and following the order of operations. The last problem is go ahead and doing a synthetic division problem with fractions. So I just made up this problem. Hopefully it's going to work. So you could use long division from here, but the student said to use synthetic division. So as long as my divisor is raised to the first power, I can use synthetic division. This problem up here, you can see my divisor was not to the first power. Therefore, that's why I could not use long synthetic division. Well, thank you very much, Jimmy Wagner. You caught my attention with your super chat. I really do appreciate that. Thank you so much. Now I see, doesn't 6 seem like he's trying to find the derivative in trigonometric substitution? What? I'm not sure what that was going through. All right, so if we're going to do this for synthetic division, there's a couple points we need to make. First of all, and this is actually set up for long division, as you can see. But since it's to the first power, we're going to go ahead and use it in long division. I'm sorry, synthetic division. I'm like caught off my brain now. So a couple key points, differences for synthetic division. First of all, synthetic division, we're not going to divide with this divisor or as the factor. What we're going to do is we're going to set our factor equal to 0 to find the 0 of this potential polynomial, of the potential 0 of the polynomial. So therefore, add the 1, divide by 2, x equals 1/2. So that's how the student is going to get the fraction for synthetic division. So now you take this 0 here, or potential 0, and you put it on the outside, 1/2. And then we'll just take all of our terms of coefficients of our dividend and just go ahead and list them. Now, again, remember, if you do not have a term, like if you didn't have an x squared or if we didn't have a 6x, make sure you use a place value. So I showed you how to use place values for long division. You didn't have to do that though. But for synthetic division, you need to make sure you have that place value. All right, so the first thing we're going to do is I'm going to bring down the 4. Now 4 times 1/2 is going to be 2. Okay, so you always multiply in diagonal. So 4 times 1/2 is 2. And then negative 2 plus 2 is 0. 0 times 1/2 is 0. 6 plus 0 is 6. 6 times 1/2 is going to be 3. And then 8 plus 3 is 11. Now we can go ahead and write this as our remainder, our constant, our linear coefficient, and our quadratic coefficient. But if you recall, this is not actually giving us the full answer in this case, because if you think about it, if you were to do long division, remember the first thing I told you to do, like take your 2x and divide it into 4x cubed. Well, 2x divides into 4x cubed to 2x squared times. Okay, so we know that the first term here should be 2x squared, not 4x squared. So what that means is what we need to do is synthetic division is actually not going to give us our perfect answer in this case. What we're going to need to do is divide everything by 2. So what we'll have is 2x squared plus 3 plus 11/2 as my remainder. And again, remember, you can always take your remainder and put it over and your terms of your divisor. This problem, I don't even recall ever having something like this, over your 11/2. I'll just write it as there. So then you take your remainder and then put it over your divisor. And then obviously you could go ahead and simplify that. But again, I made up the problem because the student didn't give me a problem. And so you can multiply by the reciprocal, but I don't want to get into anything crazy like that for that, because most of the time you're not going to have something crazy. Just make sure you understand if you're doing synthetic division with fractions, make sure you adjust your final answer. And again, you can always